equal to its absorptivity equal to its absorptivity when it is in thermal equilibrium with the surroundings. Epsilon is MCV, alpha is absorptive. So we can prove this by taking a simple geometrical arrangement wherein there is a small body, right, inside a large enclosure. This is a small body in a large enclosure. So this is the large enclosure. And this is a small body. Now let us assume this is at some temperature T, whatever temperature it is, and because of its temperature, whenever it is greater than 0, it emits the energy or radiation is coming out of this, and of the energy that is coming out of this, right, some will fall on this. Okay, so just to avoid confusion of arrow marks, I am removing this. You can understand that this is a small body, or else we can show it from outside, right? This is a small body. Now the radiation that is falling on a body, assuming it as irradiation. Radiation is energy leaving the body, irradiation is energy falling on the body. And also by its own nature, this body also emits with some energy, which we call it as emissive power, right? So now this irradiation G is a function of, if you see, irradiation G is a function of, firstly the temperature, right? The temperature of the enclosure. Now, secondly, the geometrical positioning or the arrangement of this body with respect to this. See, how much of the energy coming out of this is hitting this depends on the size, shape and form of this body with respect to this. Suppose as the size of this body reduces, the amount of energy that is falling on it will be reduced, right? Or if it increases, it increases. So therefore, it depends on the temperature and geometry of the body with respect, or geometrical arrangement between the body and the enclosure. Now, if you consider this body as very, very small compared to the enclosure, then the effect of geometry is very minimal. It is almost negligible. So in such a case, the irradiation is a function of temperature only. Right. Now the body that we have considered is black body. So for a black body, it is a perfect emitter as well as absorber. So all the energy that is falling on it is absorbed by it. Right. So now, see, energy is coming on this, some of it is hitting on it, and then the energy is going out of this. This process is happening. Now at certain point of time, we will reach thermal equilibrium condition between the body and the enclosure. So at such a condition, when will you say it is thermal equilibrium? the temperature of this body is not changing. So when is it possible? The energy received by it must be equal to the energy, right, leaving this body. Okay. So now, what is the energy that is absorbed by this? See, at thermal equilibrium, energy, or rather than energy is general in nature. Let's say radiation energy. Radiation energy absorbed by the body is equal to radiation energy emitted by the body, right? That is, incoming energy is equal to outgoing energy. Now, out of G, how much is absorbed by this? How do you find? By definition, what is the, see, that means what we are saying here is G absorbed is equal to emitted energy. But by definition, absorptivity is equal to the energy that is absorbed by body to the total energy that is falling on it. That is the fraction of the energy absorbed, right? Similarly, reflectivity and transmittivity. That is how we have defined these radiation properties. So now, G absorbed is equal to alpha into G is equal to E. So now, G is equal to E by alpha. Now, at thermal equilibrium condition, G is a function of temperature only. So this is one form of Kirchhoff's law. The other form is, now in the above equation, if alpha is equal to 1, then what happens to E? E is EB, right? Now this equation can be written as G is equal to E by alpha. When alpha is 1, E becomes EB. Now, we also know that by definition, emissivity is equal to emissive power of any body by emissivity of a black body. So therefore again, this equation can be written as this one, right? This equation now, by making use of this definition, can be taken as G is equal to E by alpha, which is equal to EB by 1, or simply EB. So now EB is equal to what? Capital E by epsilon, right? So EB is equal to E by epsilon. So E by epsilon. Now see this, right? Consider this. In this, E by alpha is equal to E by epsilon. So from this, what do you get? Alpha is equal to absorptivity is equal to emissivity. So this is the Kirchhoff's law. Please make a